Hello everyone and welcome to our first module. Today we are diving into the absolute basics with a lesson called Numbers Foundation. We're going to start strong by focusing on two main objectives for this session. First, this lesson would help you identify, classify, and feel confident working with all different types of numbers you would encounter in maths. Second, this module is crucial because it lays the foundation for more difficult topics like estimation and decimal places. Think of this as building a strong foundation for a house. We want to make sure the base is solid before we start building the walls. Let's get started. The first concept is the difference between natural numbers and whole numbers. Natural numbers are the counting numbers. They are positive whole numbers and they are the numbers we naturally start with when we count objects in the real world. 1, 2, 3, 4 and so on, continuing to infinity. If you are counting anything, you would normally start at 1. On the other hand, the whole numbers are almost identical to the natural numbers with just one crucial addition, the number 0. The set of whole numbers includes all natural numbers plus that single powerful digit 0. So the sequence for whole numbers is 0, then 1, 2, 3, 4 and so on. The key takeaway is that every natural number is also a whole number, but not every whole number is a natural number because 0 is the exception. Our next type of numbers are integers. An integer is simply a whole number that can be positive, negative or 0. It is the entire number line without any fractions or decimals, just the solid whole numbers stretching to infinity in both positive and negative directions. We can break integers down into three distinct types. Negative integers. These are the whole numbers less than 0, like -1, -2, -3, and so on to negative infinity. These numbers are to the left of 0 on the number line. We use these for describing things like freezing temperatures below 0 degrees Celsius. Secondly, there is 0, a single integer in the middle. It is unique because it is a neutral integer. It is the only number that is neither positive nor negative. Thirdly, we have positive integers. These are the whole numbers greater than 0, that is 1, 2, 3, and so on to infinity. Overall, integers give us a full range of whole numbers that are positive, negative, or 0. Also, don't forget that the positive integers are the natural numbers we touched on earlier, while the positive integers plus 0 is the set of whole numbers. So far, we have covered natural numbers, whole numbers, and integers. Now we'll take a look at how integers are categorized based on their divisibility by 2, that is, even and odd numbers. An even number is any integer that is exactly divisible by 2. When you divide an even number by 2, it always results in a whole number with no remainder. Other key factors about even numbers, especially very large ones, are that they end in 0, 2, 4, 6, or 8, that is, the small even numbers below 10. It is important to remember that this also applies to negative integers. Numbers like -2, -4, and -10, even -58 or -100 are also even numbers because they can be divided by 2 with no remainder. 0 is also an even number because it can be divided by 2 with no remainder. Odd numbers, by contrast, are any integers that cannot be divided exactly by 2. When you divide an odd number by 2, it always leaves a remainder of 1. For example, 3 divided by 2 is 1 remainder 1, 19 divided by 2 is 9 remainder 1. The last digit of an odd number, especially large odd numbers, always end in 1, 3, 5, 7, or 9. That is, smaller odd numbers less than 10. Just like even numbers, negatives are included in odd numbers. Numbers such as -1, -3, -9, -57 are all odd numbers. Moving on from integers, let's look at how we classify positive integers based on their factors. The next major concepts are prime versus composite numbers. A prime number is defined as any whole number greater than 1 that has exactly 2 factors, 1 and itself. Think of it as a number that can only be divided by 1 and itself without any reminders. The smallest prime number is 2, and it is unique because it is the only even prime number. All other even numbers are divisible by 2, giving them at least 3 factors, 1, 2, and themselves. Other examples of prime numbers are 3, 5, 7, 11, and so on. As you can see with number 7 here, its only factors are 1 and 7. Also, 19 has factors 1 and 19 only. On the other side of the spectrum, we have composite numbers. A composite number is any positive integer greater than 1 that has more than 2 factors. For example, the number 9 can be factored into 1, 3, and 9, giving it 3 factors. The number 18 has many factors, 1, 2, 3, 6, 9, and 18. Because they have more than just 1 and themselves as factors, they are composite numbers. One important exception to remember is the number 1. 1 is not a prime number, and it is not a composite number either. The definition of a prime number requires exactly two different positive factors. The number 1 has only one factor itself, so it does not meet the definition of a prime number. Now we move on to apply all we have learned with some worked examples. In this first example, the question is 53 a prime or composite number? To answer this, we need to recall the definitions we just discussed. A prime number has exactly two factors, 1 and itself. A composite number has more than two factors. The first step in our example is to find the factors of 53. We need to determine if any number other than 1 and 53 divides 53 without any remainder. If we test numbers like 2, 3, 4, 5, 6, and so on, we quickly find that none of them results in a whole number when dividing 53. We can see this from the table that a 2 divides 53 with a remainder of 1, 3 divides 53 with a remainder of 2, and so on. Therefore, the only factors are 1 and 53. Since 53 has only these two specific factors, it perfectly meets the criteria of a prime number. Therefore, the answer for this example is that 53 is a prime number. Building on our understanding of integers, let's look at another worked example to see how these definitions apply on a number line. Example, identify what type of number -4 is. To solve this, we look at where the number sits in relation to 0. The number sits below 0 as you can see on the number line. -4 is located to the left of 0. This immediately tells us it is a negative value. Also, because it is a solid whole number without any fractional part or decimal part, it fits our definition of an integer. We classify it specifically as a negative integer. On our number line, you can see the arrow pointing left from 0, highlighting that any whole number in this direction falls in the negative integer category. To wrap up our lesson on number foundation, let's put everything we've learned into practice. Here are some questions to test your knowledge on natural numbers, integers, even numbers, odd numbers, and prime versus composite numbers. Let's walk through these together, just to give you some insight as you think of the answers to these questions. Question 1. Write the first 5 natural numbers. Think back to our definition. Natural numbers are our counting numbers starting from 1, so the first 5 should be very obvious. Question 2. Write 3 integers less than 0. Remember, integers less than 0 are negative whole numbers. You can choose any 3 numbers. Question 3. Is 15 an even or odd number? Look at the last digit. Since it ends in an odd number, it should provide clarity on what type of number 15 is. Question 4. Is 21 a prime or a composite number? To find out, we check for factors. Besides 1 and 21, does anything else go into 21 without any reminders? Question 5. True or false? Is 1 a prime number? This is a tricky one. Recall our special exception. A prime number must have exactly 2 factors.